This section will cover core lean concepts and tools. This section will take approximately 20 minutes to be completed. This section will cover the following topics: core lean concepts, basic lean tools. Key lean concepts include the theory of constraints, lean thinking, continuous flow, non-value added activities, and lead time reduction. The next few slides will briefly introduce you to these 5 concepts of lean. The theory of constraints takes a systems approach. Just like a chain is as strong as its weakest link, a process is just as fast as its slowest sub-process. Most organizations identify improvement opportunities and execute them in departmental silos. Imagine each of the individual links in a chain as separate departments. If some department strengthens their link, it will not make the chain any stronger, as long as the weakest link does not become stronger. Similarly, in a process situation, if we make other parts of the process faster without improving the bottleneck, it will lead to making the process even more uneven, resulting in higher backlogs at the bottleneck. There are 5 steps to improve the rate at the constraint. Identify the constraint. This is often the workstation that has most of the backlog or inventory buildup or work in progress. Exploit lean tools such as Kaizen to identify and eliminate wastes and improve the rate of flow at the bottleneck. Match the rates of the other parts of the process to the constraint. Keep improving until a new constraint is identified. Repeat these steps with the new constraint after the first one is fixed. To improve the system, the constraint must be improved. Traditional processes are based on forecasts to drive production. Push system. Push systems result in excess inventory and lost sales due to imperfect forecasting. A pull system is driven by customer orders that initiate the process. The customer order initiates orders for component parts or information that are delivered at scheduled times. Each activity moves a component, service, or information through the process so that it arrives at the next activity when it is needed. Achieving a pull system requires flexibility in allocating resources to the required activities. Cross-training is essential for achieving people flexibility. This flexibility results in decreased works in progress, or WIP. In continuous flow, the goal is that the product or service is constantly being transformed at the speed at which customers need it. The product or service is never waiting for components, information, or any other resources. Even in transactional processes, without any physical production, this concept can be applied. For example, in a call center, instead of pushing calls to specific customer service agents, as these agents become available, they pull the calls from a holding area. This ensures that agents have similar workloads, all callers have uniform wait times, and we can accurately predict the waiting times for callers. Non-value added activities are those activities that do not change the form or function of the product or service. Customers not willing to pay for them. An overwhelming portion of lead time, which is the amount of time required to meet a customer request or demand, is comprised of non-value added activities. There are 8 categories of wastes. Tim Woods is an easy way to remember the wastes that we need to remove in lean thinking. Transportation is where products or information are moved around too much, delaying the time it takes to get them to the customer. Inventory is the storage of too much information or products that are not currently needed by the customer. Motion is too much movement for our people, as they do things that are not adding value for our customer. Waiting is where processes or people are waiting for the previous process or person to provide them with what they need for the customer. Overprocessing is where we do more than the customer needs, such as too many approvers for a document. Overproduction is when we produce more than our customer currently needs. Defects are quality issues that will affect our customer's perception of the product or service that they receive. Skills are where we have failed to utilize the skills of our employees to maximize the customer value. Where waste exists, our cost will be higher, service level lower, and lead time longer for our customer. Lead time is the total elapsed time to complete a process for one product or service. Reducing variability in lead times makes the process more predictable. Value stream maps are useful to show lead times. Lead times are reduced by eliminating non-value added components, which is the biggest opportunity for lead time reduction, or increasing speed of value added components. Work in process or inventory and lead time are related by a principle called Little's Law. In simple words, Little's Law states that if you know how much work you have to do and you know how fast you work, you should be able to know how long it'll take you to complete the work. In Lean, Little's Law is used to determine process lead times. One of the critical factors of lead time is the amount of inventory or work in process in a system. The equation for Little's Law states that the lead time is equal to work in process inventory divided by completion rate. To reduce the lead time, we must either increase the completion rate or reduce the work in process inventory. Little's Law defines the relationships that dictate how long it will take to complete work tasks in any process. By establishing the defining relations driving cycle time, Little's Law can provide an understanding of process efficiency. For example, in an IT help desk, there are 100 outstanding tickets. The help desk closes 25 tickets a day on average. Here, the help desk can predict and advise people raising tickets that it will take approximately 4 days to have the IT issue resolved. This was calculated from the number of work in process or tickets in the system, that is 100, divided by the completion rate of the help desk, which is 25 per day. Takt is a German word that means to keep in step, keep time, and stay in rhythm. The underlying rhythm is the customer demand. For example, takt time can be expressed as an insurance company approving an insurance reimbursement every 60 minutes, or a motorcycle manufacturer producing a motorbike every 15 hours. Takt is the time interval at which each consecutive output will be delivered regardless of what the output is. Takt time is a critical element of flow as it sets the pace of a process. Establishing the rate at which the product and service should move through the process allows us to maintain an appropriate pace to meet customer demand. Takt time is calculated by dividing the time available to work by the customer demand. It is expressed as the time needed to create a product or service. Ideally, each process step should take slightly less time than the takt time. Longer times can create bottlenecks. For example, a factory needs to produce 100 widgets in a day or 8 hours. Employees at the plant take a 30-minute lunch break and 2 15-minute breaks. So the available time in a day is 7 hours or 420 minutes. Here, takt time will be available time divided by customer demand, or 420 seconds divided by 100 units. The takt time is 4.2 minutes. Workload balancing compares the cycle times of the resources to the takt time. The purpose is to reveal bottlenecks, uneven flow, and overburden resources. By using a simple graph like the one shown here, we can see the time taken by each of the process steps. The graph on the left shows that the work is unbalanced. The goal is to balance the process steps by eliminating, combining, reducing, or simplifying the various tasks within the process steps. The ideal workload balance is to have all resource cycle times slightly less than the takt time. Value stream mapping is a tool that allows you to see the process flow, information flow, and the material flow of a product or service. In general, a value stream map is used to identify waste in and between processes and process steps. Value stream maps provide more information than process maps, like detailed process data, inventory data, information on quality and defect rates in the various process steps, lead times of individual steps, as well as over-process lead time. We use value stream mapping in the following 4 steps: mapping the current state, create an ideal future state map, eliminate all non-value added activities, creating improvement plans to move from current to future state, implementing the improvement plans. Value stream maps are useful to select projects, identify focus areas, and map the future state process. Even though Kaizen means continuous and never-ending improvement, in contrast, Kaizen event is a focused improvement activity in an intense blitz. Kaizen events are focused on non-value added activities. Kaizen events focus a small team on a particular work area for a short-term activity. The duration of a Kaizen event is normally between 3 to 5 days. Teams are composed of the process experts and representatives from all parts of the process. These people bring the end-to-end process knowledge. The teams question everything about the process, try out some new ideas, and make recommendations and improvements. Kaizen events help implement quick wins, which is one of the success factors in any change management process. Making workplaces visual is very important for lean enterprises. We may not realize it, but visual management is part of our everyday life. Without visual management, many factors of our life would descend into chaos. Imagine driving a car on a major roadway without the items shown on the slide. Failing to follow work instructions is a common source of process variability. Clear signs, labels, and accessible standard operating procedures help reduce variability. Just observing the work area should provide clear indications of the process flow. Making the process visible helps identify areas of waste and non-compliance. Standard work is the technique used to achieve consistent performance by creating a uniformly applied method of doing a task. The objective of standard work is to be consistent in the output irrespective of who is doing the task. Consistency being the goal, the team members must agree on the best method and then follow it. They may then test and revise the method as needed using data from the tests. The people who will actually perform the tasks are actively engaged in setting, following, and evaluating the standard work. Lack of standardized work leads to process imbalance, which in turn generates wastes, resulting in disrupting flow. The best way to create standard work is to capture the know-how and expertise of the people doing the process. This represents the intellectual capital of the process and ensures the best method is executed. To create standard work, we follow a 3-step method. First, create a value stream map of the process and get agreement from all involved on how the process works. Then, capture all the individual methods for each task and determine the optimum method, ideally using data on quality and cycle time. And finally, confirm agreement with the team. Document the optimal method, training the team, and establish necessary controls to sustain this method. In this section, we were introduced to the Lean core, Lean concepts, and basic Lean tools.